Morning, my name is Tom Maskell. I represent Combline Sanderson. We're here at the Upper Blackstone Wastewater Treatment Plant Training Facility. We're going to review a Combline Sanderson belt filter press PowerPoint presentation on operation and maintenance training of the newly installed belt filter press. Whenever you call Combline Sanderson, like I said in previous training, always refer to that job number, which is S4042. We put a disclaimer in the presentation in case I misquote something, say something. The presentation is used at the owner or operator's own risk and is not intended to be relied upon as, nor is it to be used as a substitute for safe operating in accordance with the application industry standards, including but not limited to OSHA training, safety instructions, and a Combline Sanderson operation and maintenance manual. I put this little slide in there to get a point across. It's very important to listen to what I'm saying. As this slide says, I said sit, you idiot. Some of the different pieces of equipment that Combline Sanderson manufactures. We manufacture pumps, clarification equipment, thickening equipment, dewatering, and drying. Today we're discussing the dewatering equipment, which is the belt filter press. This is the Combline Sanderson great headquarters in Peapack, New Jersey. This is where we manufacture and assemble all the Combline Sanderson equipment. We've been there since 1946. I believe the first filter went out of that building in 1949. So we have a long history there. We pride ourselves on experience, quality equipment, and service. This slide is a picture of belt filter press number 4 that we're putting into operation on the second floor in the dewatering building. Next section we're going to be covering is belt filter press safety. Reference section 1, page 1 in the Combline Sanderson O&M manual for safety instructions. Observe all local safety codes and OSHA regulations. Do not operate the equipment under unsafe conditions. The instruction manual must be read and thoroughly understood by those responsible for the installation, operation, and maintenance of the equipment. Operators must be trained for the proper and safe use of the equipment, and that's what we're doing here today. We're doing some operator and maintenance training. All guards must be in place while the equipment is running to protect against bodily injury. The equipment should always be stopped before any attempt is made to repair, maintain, climb on, or remove trapped material. Do not put your hands, feet, or any part of your body in the equipment while it is running. On this machine there are 4 emergency trip cords. They're red cables that go across the top and bottom on each side of the press. That should be your stopping point of putting any part of your body past those red cords. Do not operate the equipment while wearing jewelry, loose-fitting clothing, ties, shirt sleeves, or unprotected long hair. Whatever the policy is here at Upper Blackstone, you should adhere to it. Do not operate the equipment while under the influence of medication, drugs, or alcohol. Self-explanatory. Do not operate the equipment in need of repair or service. Proper maintenance will help avoid equipment downtime, loss of production, and injury to personnel. Do not band-aid the equipment. If it's in need of repair, repair it properly. A band-aid will usually lead into a large bandage. You want to properly fix it. Electrical power must be turned off before attempting any repairs to electrical components. Lock out control panels and all starting switches. Do not, so that another person cannot accidentally start the equipment. This equipment can be started in 3 locations. from the Comline Sanderson control panel, main control panel, the SCADA screen in the bunker, and there's going to be another SCADA screen up in near the presses someplace, behind the concrete wall that they're putting up. So be careful when you're working on the press. It should be locked out properly. Do not repair or service pneumatic or hydraulic components while equipment remains connected to the pneumatic or hydraulic power supply or is under pressure. All the gauges on the hydraulic unit should be bled down to 0. Always consult the product safety data sheet before handling chemicals. Do not handle or inhale chemicals for process conditioning, cleaning, or any other purpose without the proper eye, skin, and respiratory protection. The only chemicals I know of that you'll be using on the press will be, of course, Polymer. You should have a safety data sheet available for that, and possibly a cleaning agent to help clean the belts. And if you're using that, you should also have a chemical data sheet for that. Observe and follow all caution warning labels at various locations on the equipment. This is one example of one of the safety data sheets, safety labels that are on the press. And a lot of them are in dual languages, mostly English and Spanish. Then we get into next section is called belt press design. This is a typical layout of a belt filter press system, and we typically like to supply a system, so we're responsible for everything. Basic sludge dewatering system consists of the following items. Of course, a belt filter press, a hydraulic power unit, belt wash booster pump, a sludge feed pump, polymer preparation and feed equipment, and a polymer sludge mixing device. Dewatering sludge cake pump, and operator training. The belt press and its auxiliary equipment make up a sludge dewatering system. Manufacturers prefer to furnish the complete belt press system, as this practice assures owners and design engineers that all accessories are suitable for the system, and the responsibility for the service and warranty is with a single manufacturer. Some engineers and owners like it, some of them don't. We prefer to supply everything. Basically, the compress has 3 zones, designed to dewater the solids and produce the driest sludge cake. These zones are the gravity zone, wedge zone, pressure zone. Regardless of the machine design, either a 2-belt or a 3-belt, the basic operation of the compress is the same. We are supplying 3-belt machines here at Upper Blackstone. And for general information of this slide show, previous day's results, we were averaging 26.5% cake solids. We only had to achieve 25, so we're exceeding that part of the spec. It's another design picture that we have in our O&M book. It gives you the different items that are located on the press. The sludge distribution box, the mixing valves, the polymer injection ring, the sludge feed, the belt tensioning roller. It describes a lot of things that are on the press. This can be found in your O&M book. Polymer and sludge mixing. The polymer is pumped into the sludge feed line through a 4-point injection ring, which is located just prior to the mixing valve. The sludge with the polymer then passes through a variable orifice mixing valve where the turbulence and shear forces provide instant and complete mixing of the polymer with the sludge solids. Here at Upper Blackstone, they're using their own twin mixing valves. We typically supply our own mixing valve. Here, because of the solids are so high, they use this design, which gives them real good flocculation and cake results. This is our flocculation tank. After the sludge passes through the injection ring, goes through the mixing valves, and comes up through the conditioning tank, the flocculation tank, and up into the feed distribution box. After the polymer sludge mixing, the conditioned sludge passes into the flocculation tank section of the flooded bottom distributor, which is designed to allow significant residence time for effective flock formation. The flock formation should be what we in the industry look for. It looks like popcorn, or some people make it, they call it cottage cheese. It's a slightly different color, but it's the same consistency. At the same time, this provides a uniform, gentle upward flow and distributes the feed solids across the full width of the filter belt in the gravity zone. And that full width is very important. We want to distribute the sludge across the full width of the belt because on the previous presses, sometimes you weren't getting that, and that would lead to belt misalignments. This feed distribution device that we supply nowadays works really well and gives us that even distribution across the full width of the gravity zone. In the gravity zone, we have these, what we call rotocone plows. This is the new generation of plows. The first two rows where the sludge seeds are called rotocone low profile, which are 15 degrees in diameter, in height. The one that's closest to us on this slide, they're the rotocone high profile, which are 30 degree in height. We combine 2 rows of low profile and 4 rows of high profile, and it gives us really good dewatering in a gravity zone. After thickening in the gravity zone, the sludge passes to an adjustable wedge zone, which has been designed to gently apply pressure to the thickened sludge as it's sandwiched between the 2 pressure belts. The wedge zone prepares the sludge by removing additional water so that it will accept the higher pressure applied in the pressure zone. The arrow is pointing to the beginning of the wedge zone. After it goes through the gravity zone, falls down in the gravity to wedge distribution tray onto the wedge zone. After the sludge solids have been sandwiched between the 2 pressure belts in the wedge zone, they are carried around a series of drums. These drums are positioned so that the belt carries the formed cake over and under the drums, applying pressure and shear as they pass through the zone. Typically, after the perforated drum, we supply a large solid drum, and as the belt travels back, the drums get smaller and smaller. Smaller the drum, the higher the pressure. And the arrow is pointing to some of the drums in the pressure section. The big, large black drum is the beginning of the pressure zone, and it travels all the way back to the discharge. Once desired operating conditions and the plant operating conditions have been established and stabilized, the compress can be operated in either manual or semi-automatic mode. Periodic checks and sampling during the operating day are always desirable to take note of possible malfunctions and maintenance needs, and to keep a proper log of maintenance performance. Machine performance, sorry. Anaerobically digested sludge. These are some of the types of sludges that we typically deal with throughout the world. Waste activated, WAS sludge, aerobically digested sludge, and primary sludge. In the slide next, picture that's on this slide, the dish on the right is what we get off the gravity zone. The dish on the left is what we get off the discharge. The glass on the beaker on the right is what we see in the feed box. And the beaker on the left is typically what the filtrate looks like. So you get a good example of what the things you should be looking for. Now we get into the press components. The 4-point polymer injection ring. You get a polymer, a common polymer line. It comes from the polymer pump, and it breaks off into 4 tubes which go into the injection ring. So when the sludge comes up from down from the pump, it gets hit in 4 different places, and you get a real good flock formulation. And here again is the twin mixing valves that are supplied by the plant. Now that the sludge has been polymerized, it goes through those 2 mixed valves, forms the flock, and travels up to the press. We also installed a 4-inch drain line to drain that conditioning tank, or flocculation tank. Some people call it flocculation tank, some people call it conditioning tank. Whatever you want to call it, it's a tank, and you can drain it. One of the issues that was brought up by some of the operators, that the valve stays closed for a long period of time because they're operating, the sludge solids become solid in there, and the line will not drain. They recommend putting it in a flushing line. So I got to talk to CDM and the contractor about putting a flushing line in that drain line. The flooded bottom distribution feed box is what you're looking at. The blue probe, the Drexel Book probe, is a high sludge level probe. If the sludge should raise up and touch the probe, it will shut the sludge and polymer off, preventing the sludge from overflowing on the press. Here's a picture of your rotocone plows. It gives you a real good idea of what I'm talking about when I say 15 degree and 30 degree. The bottom plow on the right is a 15 degree, and a plow on the right on top is a 30 degree. You can see the height of the plow is a lot different. The first 2 rows are the low profile on the bottom right, and the last 4 rows are the high profile up on the right, top right. It's a slide of a plow lifting handle. This is a slide that shows you the hand retractable spring plunger. You pull the pin to lift and release to lock the row of plows for cleaning and filter belt replacement. Hydraulic tracking and tensioning unit. This is the hydraulic power unit for steering and tension. This is a slide of a hydraulic flow control valve. Each one of your steering cylinders has a flow control valve to control the amount of oil going to that cylinder. Depending on how fast you want that cylinder to travel is how far open you open that valve. Once I set that flow control valve, you should not have to touch it. Unless you want to isolate the oil to that cylinder to work on it, what we recommend is that you count the amount of turns when you close it, and when you go to reopen it after you completed your work, count those turns back to the open position. These are your hydraulic directional control valves for your 2 pressure belts, for your upper pressure and lower pressure belt. When you're running the press, they're going to be in advance. When you're changing the belt and you're working on the press and you want the belts to be retracted, you turn the arm to retract, and the belts will retract. This is one of the 3 belt tracking sensors that are on this press. This is your lower belt tracking sensor. They all look the same with the exception of the paddles. On the gravity belt and the upper pressure belt, the paddles are a different shape. This slide is a picture of your steering cylinder. It's a short, fat cylinder with a 5-inch stroke. This slide shows you the tensioning cylinder, which is a 12-inch stroke, a little skinnier and longer. So you can identify both of them. The gravity tension is mechanically taken up. This is a slide of your Washwater booster pump. This is a picture of your wash box clean out plug. Periodically, every month or every couple of months, as long as you periodically take the plug out and hose the inside of the wash box out, we'll be happy. This is your Washwater spray header. Very, very important. I can't stress it enough. Very important for the operator to operate all three of those spray header handle that clean the nozzles. Rotate it fully counterclockwise until it stops, and fully clockwise again until it stops. When what you're doing is when you rotate that blue handle, inside that pipe there's some stainless steel brushes. And those brushes clean the nozzles. Clean nozzle, good performance. Dirty nozzle, poor performance. So it's very, very important. I know I've heard a lot from the operators that they never do it. You should be doing it. Maybe your belts will last a little longer. Right? Very important. Catwalks. Usually the catwalks are made out of aluminum, fiberglass, and stainless steel. From what I understand, they're going to get some input from the operators. Right now, presently, you have a wooden catwalk up there. You're going to be getting a aluminum catwalk made locally. Next, we get into the electrical components on the press.